parametric distributions or parametric probability distributions. Why do you need these probability distributions? The first thing is, whenever you have any particular data set, let's say you have data saying x1, x2, x3 and so on. Let's say there are n particular data points. You will always be able to map your data to some particular probability distribution. That is, if you have some data points, there will be some particular distribution from which these data points are derived. That is, data would never come from some total randomness. It will always be coming from some sort of a regularity, some sort of a distribution. So if you have some data set, there will be infinite number of distribution from which this can come, but it's important that you identify the right distribution or the appropriate distribution from which your data is coming. So once you identify that, it will be easier for you to map all the characteristics of this data and to identify how this data would behave. So what is a distribution? It is basically, you can identify it as a mathematical formula or something from which you can identify the origin of this data. That is, during model selection, that is, we were trying to find the right polynomial, something like this, that is y equal to w0 plus w1x plus w2x square plus dot dot dot, like this. So while we were doing this, we were trying to find an equation from which your data can be derived. That is, the xy coordinates of your data can be derived. If there is some particular value of x, from that you were able to derive y. And so in the Cartesian plane, you will be able to get each point from this equation. Similarly, you are trying to model a distribution. Once you have this distribution, from this distribution, you should be able to identify each of your data points. So why is this called a parametric distribution? Why is this called a parametric distribution? Because let us say you have a dog. How would you identify your dog specially from all the dogs? That is maybe by its name. Similarly, let's say you have a Gaussian distribution. So there will be a lot of Gaussian distributions. From this, how do you identify one particular Gaussian distribution? That is by the parameters. So parameters can be something like the mean of the distribution or the variance of the distribution. These are the parameters which uniquely identify this distribution. That is, if there is some particular Gaussian distribution, how will I tell you that these are the characteristics of my distribution? I can't simply draw the picture and tell you, see, the point at this, it is this. For x of this is the value of y. That is not the way. Instead, if I tell you that mean of my distribution is 0 and variance is something, from these two values, you will be able to uniquely identify one particular Gaussian distribution. That is why these are called parametric distributions. That is, from the parameters, you will be able to uniquely identify any particular distribution. So then the question is, how do you identify the parameters of your distribution? So here, coming to the approach, it will differ. That is, if you are having the classical approach, we already discussed about classical and Bayesian approach for probability. Coming to the classical approach, what you will do? You will find the parameters by optimizing some criteria. That is something like the likelihood function. You would optimize and reach the particular parameters. And if it's the Bayesian model, then what do? You have a prior. See, coming to the Bayesian model, you'll always have a prior assumption, then this is my distribution. So from the prior assumption, what will you do? According to the data that you have, you will modify the prior by using the Bayes theorem. You will use the Bayes theorem, modify the prior, and you will reach the posterior. The posterior that you finally find, from that is your final distribution, right? So this is the basic about parametric distribution. We will be looking into what are the different types of parametric distributions. We'll go into Bernoulli distribution, binomial distribution, Gaussian distribution, right? These things we'll learn in the coming lectures.